This content is produced by Pass the CSLB, an independent audio-first study companion for busy California B general candidates. I build these lessons from official CSLB study guide topics and reputable source-backed California materials so you can study on the go. This is exam prep reinforcement, not legal, professional, engineering, or job-specific advice. Exam content is set by PSI and the CSLB and may change, so always verify current requirements against official CSLB materials. No exam outcome is guaranteed. Now let's get into it. A wood structural panel does not become a working shear panel merely because it is nailed onto a wall. The panel works only when force can move through a continuous chain of framing, fasteners, sheathing, plates, and anchorage. For field supervision, the heart of this lesson is simple. Every perimeter fastener needs sound panel material on one side and real framing or solid blocking on the other. If either side of that connection is missing or damaged, the fastener can look installed while the intended shear transfer is weakened or absent at that point. Imagine a contractor who walks the exterior of a newly sheathed wall and sees a straight row of nail heads. From that side, the work looks clean. Then the contractor steps inside the frame building. Several nail shafts are shining in the stud bays because they missed the framing. A horizontal panel joint has no blocking behind it. Along another edge, a few nail heads are buried through the outer veneer. Those are 3 different defects, but they all break the same basic promise. The nail must connect usable panel material to usable framing. I want you to picture the load path without turning this into an engineering lecture. Lateral force from the roof or floor reaches the wall framing. The framing transfers that force through the fasteners into the wood structural panel. The panel carries the racking force toward the bottom of the wall, and the bottom of the wall transfers it into the anchorage and foundation. Every connection in that path has a job. That is why nailing is not just a finished detail. A row of fasteners is part of the structural transfer mechanism. A missed stud is not merely ugly. It means that fastener did not make the intended connection. An unsupported panel seam is not merely inconvenient. It means the edge fasteners do not have the required backing. An overdriven head is not merely a cosmetic dimple. It can crush the panel face that the nail head depends on for bearing. The useful supervision question is not, does the wall have enough nails when viewed from 10 feet away? The useful question is, does each required fastening zone have the support, placement, and nail seating shown by the approved structural information? That question keeps attention on the load path instead of on appearances. I also want to separate design from execution. A general building contractor does not invent a shear schedule in the field. The plans, structural details, applicable code, and responsible design authority establish the required panel, fastener, spacing, framing, and anchorage. The contractor's job is to coordinate that information, build it correctly, recognize defects, and stop concealment when the work does not match. The first distinction to lock in is edge nailing versus field nailing. The edge is the perimeter of the panel, including joints where one panel meets another. The field is the intermediate framing inside the panel area. Those zones do different work in the fastening schedule, so they are not interchangeable. Looking at this comparison, the key pattern is that edge nailing is generally tighter and field nailing is generally wider, but the exact spacing comes from the approved schedule. Edge fasteners transfer force around the panel boundary and across supported panel joints. Field fasteners connect the panel to intermediate framing and help keep the panel engaged without substituting for the perimeter connection. A common field mistake is to read one spacing note and apply it everywhere. Another is to measure beautiful intervals along the panel edge without confirming that the line is centered over framing. Spacing accuracy does not rescue a fastener that lands in air. I would rather see a superintendent verify the backing first, then verify the edge line, then verify the spacing, then simply count nail heads from the exterior. When I read a shear wall detail, I separate the information into 2 questions. What is required at panel edges? What is required in the field? Then I trace each panel boundary and identify what is behind it. That simple habit prevents the edge schedule from being confused with the field schedule and makes missing blocking much easier to spot. Official preparation resources identify seismic, hardware, and structural framing execution as key areas. This edge versus field distinction is testable material because it shows whether a contractor can read a schedule and supervise the installed work without turning a general rule of thumb into a substitute for the plans. Now I want to narrow the view to the thin strip of wood between a nail and the panel edge. The research report identifies a minimum edge distance of 3/8 of an inch for structural sheathing fasteners. That distance is small enough to overlook and important enough to inspect. The physical issue is straightforward. When a fastener is driven too close to the panel edge, there is less wood fiber between the nail and the open edge. Under racking force, that narrow strip can split or tear away. The nail may still be embedded in the framing, but the panel can lose its grip around the fastener. The connection then fails at the panel side. I use a simple memory connection. Edge nails need an edge, not a sliver. The goal is not to place the nail as close as possible. The goal is to keep the required distance while still landing the nail solidly in the backing. That means the framing layout, panel layout, and nail line all have to agree. Suppose a crew snaps a chalk line too close to the panel boundary and runs the nailer quickly. Adding more nails along that same bad line does not correct the geometry. It can create more damaged panel edge and more congestion in the framing. The better supervision move is to catch the line before production nailing, and if the defect already exists, stop and obtain the approved correction rather than improvising. The same inspection should look for nail heads that are properly seated, not buried through the panel face. Edge distance protects the strip beside the fastener. Proper seating protects the panel material under the head. Both conditions preserve the connection between panel and framing. A blocked shear wall requires the panel edges to be supported by and fastened to framing members or solid blocking. In practical terms, a panel seam cannot be left floating and still be treated as a blocked edge. The fasteners along that seam need real wood behind them. This checklist separates the joint profile from the structural support. A vertical panel edge may land on a stud or another framing member. A horizontal panel seam may require solid lumber blocking. In either case, the inspection question is the same. Is the entire required edge supported and fastened as shown by the structural documents? Tongue and groove sheathing creates a common confusion. The shape joint may help panels fit together, but standard tongue and groove construction should not be assumed to replace solid blocking for in-plane shear transfer. I treat the tongue and groove profile and the required structural backing as two separate questions. If the approved design does not specifically provide another accepted shear transfer method, I do not call that seam blocked merely because the panel edges interlock. Blocking is also a sequencing issue. It is easiest to verify before the wall is covered from both sides. If blocking is missing after sheathing is installed, the correction can require opening work, adding backing, renailing, and obtaining approval. That is avoidable rework when the superintendent traces panel joints before the nail crew starts. Imagine a horizontal joint halfway up a wall. From the exterior, the seam is tight and the nails appear evenly spaced. From inside, there is empty space behind the joint. Those nails may have penetrated the panel, but they did not fasten the adjoining edges to solid backing. The surface appearance hides the structural discontinuity. That is why inspection from the accessible backside is so valuable before insulation and interior finishes close the cavity. The memory connection here is simple. A blocked edge has backing, not just contact. Two panel edges touching each other are not the same as two panel edges fastened into a supporting member. Dense edge nailing creates another planning decision. When the schedule concentrates larger or closely spaced fasteners at adjoining panel edges, a standard 2 by framing member may not provide enough width for the required installation without splitting. The source-backed trigger conditions in this chart are specific. At adjoining panel edges, nails spaced at 2 inches on center require 3-inch nominal framing. The same wider framing requirement applies when 10 penny nails are spaced at 3 inches on center or less. These are not generic nailing instructions for every wall. They are conditions that tell the contractor when wider edge framing must be recognized in the plans, estimate, layout, and inspection. The mechanism matters because it makes the rule easier to remember. Closely spaced fasteners load a narrow strip of framing across the grain. If too many fasteners are crowded into the face of a standard 2 by member, the lumber can split parallel to the grain. Once the framing splits, the fasteners lose the solid wood they need for lateral and withdrawal resistance. A 3-inch nominal member provides a wider face and room for the required placement and staggering. The reference standard also allows an engineered alternative, using 2-2 by framing members connected together to transfer the induced shear. The word engineered matters. 2 studs placed beside each other are not automatically equivalent to a 3-by member for this purpose. The connection between the members must be specifically designed to transfer the force. I would not accept a casual field substitution based only on the fact that the combined lumber looks wider. This is where estimating and framing coordination meet. The widened boundary member has to be identified before the wall is closed. It can affect lumber takeoff, stud layout, panel joints, and the space available around openings. Discovering the requirement after the panel has been nailed can turn a simple material decision into demolition and renailing. The practical habit is to scan the structural schedule for the tightest edge nailing before framing begins. Then match those high-density zones to the required backing. The nailing schedule and the framing schedule are 2 sides of the same connection. Now I want to walk through the 2 defects that can fool a quick visual inspection. The first is a shiner. A shiner is a nail that passes through the panel but misses the framing. From the exterior, the head may sit in a neat row. From the interior, the exposed shaft reveals that the fastener anchored into nothing behind the panel. A shiner contributes no intended shear connection at that location. The correction is not to pretend the row is complete. The missed location has to be addressed with a properly placed fastener or another approved correction that actually engages the framing. The superintendent should also look for the cause. The chalk line may be off, the framing may have moved, the panel joint may not be centered, or the nailer may be held at an angle. Finding the pattern matters because one visible shiner can signal repeated misses along the same line. The second defect is an overdriven nail. This happens when the nail head is driven below the intended panel surface and crushes through the outer veneer or face material. The nail may have hit the framing, but the head has damaged the material that distributes force into the panel. The deeper the head is buried, the less effective panel thickness remains under that bearing area. I do not teach a universal field repair ratio for overdriven nails because the research report does not establish that supplemental industry guidance as a statewide California correction rule. The sound supervision response is to stop, identify how widespread and severe the condition is, protect the work from concealment, and obtain the correction required by the approved plans, specifications, responsible design authority, and authority having jurisdiction. Blindly adding nails can create a second problem. If the edge is already densely fastened, crowding more fasteners into the same narrow framing can increase the chance of splitting. The approved correction has to account for both the damaged panel face and the capacity of the backing. That is exactly why defect recognition and repair design are different responsibilities. Air pressure, tool adjustment, and operator technique can all affect nail seating. I do not need to guess which cause is present. I need to see the pattern, stop the production defect, verify the tool and setup, and keep defective work from being covered. A useful memory pair is this. A shiner misses the backing. An overdriven nail damages the face. One fails because there is no framing connection. The other is suspect because the panel material under the head has been crushed. Pneumatic nailer safety belongs in the same supervision conversation because the tool that installs the structural connection also carries stored energy and can discharge a fastener with serious force. For the nailers covered by the California safety rule, the muzzle must have a safety device that prevents operation unless the tool is in contact with the work surface. That contact device is a safeguard, not permission to ignore manufacturer instructions or safe handling. The jam clearing rule is even easier to remember because it requires a physical action. Before clearing a jam or performing maintenance, disconnect the air supply at the tool. I want you to picture the coupling separated in your hand. Merely taking a finger off the trigger is not the required isolation step. The cause and effect are direct. A connected hose leaves pneumatic energy available to the tool. Manipulating a lodged fastener or the nose assembly can move components that control firing. Disconnecting the supply at the tool removes the continuing air source before the hands enter the danger area. A supervisor should make the sequence ordinary and non-negotiable. Stop using the tool. Disconnect it at the coupling. Follow the manufacturer procedure for clearing or servicing it. Reconnect only after the tool is assembled, checked, and ready to return to use. Speed does not justify reaching into a connected nailer. This safety rule also helps with quality control. A crew that pauses to correct pressure, depth setting, jams, and tool condition is less likely to keep producing shiners and overdriven nails across an entire wall. Safety and structural quality meet at the same tool. When I make a final shear panel walk, I use 4 words to keep the inspection organized: support, schedule, seating, and safety. Support means every required panel edge has framing or solid blocking behind it, and the fasteners actually hit that backing. Schedule means edge and field nailing are identified separately and match the approved structural information. Seating means the nails maintain the required panel edge distance, land in the framing, and are not driven through the panel face. Safety means the nailer has the required contact safeguard and is disconnected at the tool before jam clearing or maintenance. I would perform that walk before the work is concealed. I would look at the panel face, trace every perimeter, and inspect the accessible backside for shiners and missing blocking. I would pay special attention where the schedule becomes dense, because that is where wider framing or an engineered alternative may be required. I would document defects and hold the next layer of work until the correction is approved and completed. The central idea is still the same one I started with. A shear panel is a chain of real connections. The panel edge must have enough material around the nail. The nail must be seated without crushing the face. The nail must enter real framing. The framing must be wide and sound enough for the specified pattern. The edge must be supported. When those conditions line up, the fastening can do the job assigned to it. There is an audio practice quiz for this specific episode on shear panel nailing, overdriven nails, and edge blocking. It is audio-based with each question read aloud and each answer selected by tapping, because I know you may be studying while driving, working, or moving between jobs. Go to the description below this video. You will see a link that says, Pass the CSLB. Tap it. It will take you straight there. Comment below with any questions about anything I covered. Subscribe so I can help you stay on track through every episode until you get your license. I am rooting for you, and I want the next job site decision you face to feel clearer because you put in this time.